Welcome back everyone. So in this session we are going to look upon the nature of roots. We have already learned how to find out the roots of a quadratic equation using middle term as well as Sridharacharya method. Now what I am trying to imply by saying nature of root, that whether the root is positive or negative, what are the values of that particular root, are they identical or they unique, whether they real or imaginary, that all we are going to see in this particular session. So the nature of roots, there is this formula that we know as Sridharacharya formula is very useful, b square minus 4ac upon 2a. This formula is very useful in order to determine the nature of root, and in particular this expression b square minus 4ac, this is very important. Why this is important? Let's take a look. What if this b square minus 4ac is greater than 0? If this b square minus 4ac is greater than 0, then we will be getting a particular number out of this square root, and then only this particular equation will be a real number. So what I can say over here, if b square minus 4ac is greater than 0, then both roots are real and unique. I hope it makes sense. Now what if this b square minus 4ac is equals to 0? Then what will happen? If this equation, this expression is 0, then we'll be achieving only minus b upon 2a, right? So in this case both roots are same and is equal to minus b upon 2a. I hope it is making sense, right? Now proceeding forward to our third condition. What if b square minus 4ac is less than 0? Now if this equation b square minus 4ac is less than 0, then what will happen? In real number format we can always find out the square root of positive numbers. But what if this number becomes the negative? Then we cannot find out the square root, obviously, right? And that's how, if this number becomes less than 0, then both roots will be a non-real number, that is imaginary number. Or you can say, since the both of the roots will be imaginary number, so they will be in the form of complex conjugate. Now this term complex conjugate, now this term you will be learning well in higher classes, but let's have an idea over here. See what I mean by conjugate. Conjugate is what? Conjugate is nothing but, let's say there is this number x plus y, then x minus y will be its conjugate. I hope it is making sense. For example, there is this number 2 plus root 3, then 2 minus root 3 will be its conjugate. Now what is meant by complex conjugate? So let's consider a complex number. The general form of a complex number is a plus iota b. Iota is a imaginary number, right? So that you will be learning in the higher classes, no need to worry about that. A plus iota b is a complex number, so its complex conjugate will be a minus iota b. I hope it is making sense. So whenever this b square minus 4ac will be a negative number, then both the roots will be complex conjugate of each other, that is a plus iota b and a minus iota b, right? So that is what all about nature of roots, and this is what we can learn, and this value b square minus 4ac, this is so important that we have given a particular value, that is discriminant. What we say, d is equals to b square minus 4ac. Since b square minus 4ac is such an important term that we have given it a terminology that is known as discriminant. Discriminant, right? And this discriminant is known as b square minus 4ac, right? So I hope it is clear to you that how we can represent the nature of roots. Now we'll learn what I have just told you in graphical method. So let me just summarize what we have learned till now. That is, if d is greater than 0, then what we achieve is real and unique roots. That is, both the roots are real and distinct, right? What if d is equals to 0? Then we get both the roots as same value of the roots. Now what if d is less than 0? Then we'll have imaginary roots. And we'll have imaginary roots, right? Now, any quadratic equation ax square plus bx plus c is equals to 0, if a is greater than 0, then it results in upward parabola, and if a is less than 0, then it results in downward parabola, upward and downward parabola. So what I am trying to say over here is that these three values, these three conditions can be represented separately in graph, and that is also in a very interesting manner. For example, that is a is greater than 0 and a is less than 0, right? We have two cases and we have three cases of discriminant. Now let's just try to plot these graphs separately. X-axis and y-axis, x and y, x and y. Since a will be greater than 0, so it will be a upward parabola, and if a is less than 0, then it will be a downward parabola. Right. So if I try to plot this graph, see, this graph is what d is equals to 0, and this y is what? This is the value of the function and this is the value of x, right? X is the unknown. So if I plot the parabola and we have two distinct values, so it will somehow look like this, where we have achieved two unique roots. And in the same case, it will look like this in case of a is less than 0. I hope it is clear. Now, in case of d is equals to 0, since we will be achieving only one root, so it will be just touching the x-axis. It will be just touching the x-axis, not more than that. It will not be intersecting the x-axis, right? And that's how we'll be achieving only one root. Now, what if we have d is less than 0 and we have imaginary roots? So in this case, this graph will not be touching the x-axis. This will be y and this will be x, right? So in this case, this will not be touching the x-axis, and that's how we will not be getting any real roots, and this will be followed in over here as well, right? So that's how we can represent the quadratic, various forms of quadratic equation and in various different cases. That was all about the nature of roots. Let's practice some questions.